Good morning, everyone, and welcome to Canto Conversations. My name is Teresa Wankin, and I'm your moderator for this session as we chat about optical network enhancements for accessible connectivity in the Caribbean to face our new digital reality. Our guests this morning are from one of our newly minted members of Canto, PadTech. PadTech is a Latin American company and a global provider of optical transmission solutions based on dense wave division multiplexing technology. They have a strong background in research and development of optical network solutions. Our guest this morning, I'm excited to introduce you to Hernan Yepes Montana. He is an electrical engineer and the holder of a master's in telecommunication engineering from the University of Antioquia, Colombia. He currently works as the regional manager at PadTech for South America and the CALA region. Anderson Rudiaz Sanchez is also an electrical engineer from the University of Antioquia and holds a postgraduate in project management. He is the business development manager at PadTech for CALA North region. Welcome, Anderson and Hernan, to Canto Conversations.
Hello, Teresa. Thank you so much for your introduction. We are very pleased to have you all here today. And well, first of all, I'd like to start saying that we really appreciate your time and the fact that all the people or participants are willing and able to meet us today.
Yes, thanks so much. We're excited to have you. So just to go over some housekeeping information, remember to mute your microphones and post your questions for the speakers in the chat. Kindly let us know your names when posting so we can identify you if the question requires any follow-up actions after the webinar. So I am going to ask Anderson to share his slide and take us through the first part of the presentation, where he will talk about optical network enhancements and give us some statistics about the Caribbean region.
Okay, Anderson. Teresa, thank you. I will share now my screen. And appreciate you letting me know when it starts to, when it shows up.
Yes, so we can see your screen. Thank you.
Okay, perfect. Thank you so much. Well, once again, thank you so much for your introduction and welcome everybody to this webinar of Optical Networks Enhancement for an Accessible Connectivity in the Caribbean to face our new reality. My name is Anderson Ruiz and I'm a business development for CALA North region at PadTech. My teammate, Hernan Yepes Montoya, our regional manager for CALA North, will be presenting the second part of this webinar. Okay, so for today's meeting, we have proposed an agenda which starts with a meeting purposes review, which basically what we want to do here is to point out the three key factors that I would like to point out at this webinar. And then we will talk about the COVID-19 impact on the traffic network's performance and how this has impacted the Caribbean economy. Then we'll take a look to the internet speeds in the Caribbean and what are those data traffic boosters. Once we have all this in mind and this context, we will have a technical approach on dense wavelength division multiplexing technology, which is DWDM. And we'll take a look to the DWDM architectures for metro networks, ROADM architectures and market trends. And at the end, we'll have something about our PadTech solution for metro DWDM networks. And we'll also have some time at the end to answer some questions. Okay, so our main meeting purposes starts with a review of COVID's impact in the Caribbean digital infrastructure and how this is linked to the data traffic growth. Then you'll learn how to boost your optical networks, making use of a combination of technologies such as DWDM and ROADM, which basically gives the name to this webinar. And finally, you will understand how Pactic's solution will help you to reduce both capital and operational expenditures. So let's just put some context, some of the internet data traffic over the time into context. Since its introduction in 1984, the internet traffic usage has been increasing by nature. But if we take a look to the last 20 years, we take a look to the growth of the last 20 years, this has been exponential. And this is closely related to the introduction and increasing usage of social media applications such as WhatsApp, Instagram, or gaming, for example, so on and so forth. I mean, a lot of applications that we have right now that demands a lot of traffic and data traffic growth and requires a specific bandwidth. So let's say that this market has a growing trend by nature, but let's put it like the COVID-19 has pushed it a little bit harder. Okay. So what about the COVID-19 impact on traffic networks performance? Well, Wi-Fi capacity has been stressed by an 80% increase in the personal computers uploading information to cloud computing platforms, and in addition to peaks of video conference calls. So these increases has resulted in acceleration of the capital expenditures related to the expansion of networks capacity. Okay, so COVID-19 measures that has been taken, such as closures of workplaces, home quarantine, all these situations has brought about a shift from the data traffic, shifted from business to residential access, which means that traffic no longer comes from business districts and has shifted to residential areas. And similarly, for example, a portion of data traffic has shifted from mobile to fixed Wi-Fi networks. And here the point is that there's a big challenge for all the stakeholders in the ICT business. And when I say stakeholders, I mean operators, internet service providers, integrators, suppliers or providers such as Pactic or whoever your provider is at this present time. And because all networks, traditional networks, were not prepared for this kind of traffic. Okay, so this is a big challenge for all of us at this present time. So if we take a look to this table one, some of the stakeholders or some sources such as AT&T, Facebook, Netflix, for example, have reported an usage percent increase during the pandemic, right? So, but if you take a little bit a deeper insight of this, we take a look to the Zoom, for example, and Teams, which reports increases of 300% and 775%, which is just insane. Okay, so that's the main idea for the impact of COVID-19 on the traffic network performance. So then if we take a look to the download speeds, internet download speeds in the Caribbean region, for example, according to Ookla speed test, all Caribbean countries have reported an increase on its download speeds. Obviously, some of them are higher than some others, but it will depend at the end of the many factors such as their population and the internet penetration, for example. But in general, we can say that a compound annual growth rate of the download speeds in the Caribbean from April 2020 to April this year is accounts for almost 39.6%. Here in the picture, we can see The blue bars represent the download speeds in megabits per second as April 2020. And the orange bars represent download speeds in megabits per second as April 2001, I mean this year. In the other hand, if we take a look to the upload speeds, we see that the compound annual growth rate is slightly higher than the download speeds. This is, I mean, prior to the pandemic, this was not the normal or the common thing. Okay, so that's why all of us have to consider and think of new technologies and architectures to support this new normal and data traffic growth and bandwidth it requires. So, and what about the economy in the Caribbean? Well, according to the Organization for Economics, Cooperation and Development, as the Caribbean heavily depends on travel and terms accounts for almost 14% of the GDP and 15% of the total employment as 2019, for example. So Caribbean countries must consider a transformation of their digital infrastructure to support also as a change in its production structure. If we take a look to the remittance, for example, in Haiti, it has dropped 30% and 10% in Jamaica. So this calls for a transformation, a digital transformation seriously. So if we take a look to the picture on the left at the bottom, the bars with blue and white stripes represents the connectivity, the digital industries, for example, the infrastructure on the Caribbean compared with the remaining Latin American countries. And if you take a look to this picture, you will realize that there's in its average is low compared to the remaining countries. So as a dynamizing potential for digital infrastructures or technologies, just to have an example, you can just be supported by technologies such as analytics and artificial intelligence, Internet of Things, cloud service and platforms, and so on and so forth. Okay, so what are the measures taken by operators? Well, operators, global backbone operators and regional operators have agreed that there are some measures that have been taken to deal with the COVID-19, but definitely there are a top three of these measures. And those are, for example, in first place, accelerate the domestic capacity upgrades. And that means that at this present time in the Caribbean, there are very low upload speeds, which calls for a need to migrate to GPON technologies, for example. And it will be translated to a transition from copper to fiber. In second place, the accelerate international capacity. Well, this has to be with the use of current technology for high capacity transmissions and the usage of spectrum efficiencies. And at the end, increase the pairing capacity. Well, basically what we look here is to reduce the distances across the network, which will be translated to a low cost of the network, and put the content, get it closer to the end user. But in general, all these measures that whoever adopts it, call a global backbone or a regional backbone, they must have a scalable, resilient, efficient, and automated solution. So here's another big challenge for to take these measures to deal with the COVID-19. So as a summary, we can say that the boosters for the data traffic growth are related to, has to be with every time we have even more applications more devices, even more content, even much more amount of people or users. So one of the technologies that we'll be talking about shortly is the DWDM, which stands for Dense Wavelength Division Multiplexing. And this is basically a technique used for combining or add up different signals which are tuned in a specific wavelength. And those signals could be of different natures, such as SDH, for example, SONET, video or storage protocols, okay? So let's just imagine that there are different vehicles traveling at the same time on a highway, and they're heading to different locations. So what if they got to an intersection point? Some of them are going to the east, some of them are going to the north, or going to the west, I don't know. So that's where ROADM shows up. ROADM stands for reconfigurable optical add-drop multiplexing. And basically this is going to do the big job at this intersection point. Let's just imagine that every signal or service that comes from the DWDM gets to an intersection point or to a site or a node, a client node, and the ROADM will allow you to add or drop or just let it pass through the next site this signal. Okay, and what is exciting about all this? Well, first of all, that you can do it remotely from your management system. So no personnel needs to be sent to every site to make a cross connection every time you're putting in service a new service or a new client, for example. So at the end, combining DWDM technology with ROADM technology, you'll get higher capacities through a fiber pair, but you also will get less capital and operational expenditures involved in your business, and you'll consume less time for new deployments, for example. But after this, we'll take a look to the technical approach with Hernan.
Thank you, Anderson, for the presentation. And good morning to all the people that have joined us today. I will share my screen right now.
Sure, that was a really enlightening presentation, Anderson.
Anderson, please stop sharing your screen.
Yes.
Just 1 minute, please.
Sure, take your time, guests. Remember to post your questions in the chat. I saw some interesting statistics about the Caribbean, and we will be able to share the presentation after. Right, there you go.
Okay. Can you see my screen?
Yes, we can.
So today we are going to talk a bit about DWDM technology. To start with this topic, I am going to talk a bit about fiber optics. That is a very important medium. Optical fiber is a transmission medium that is most talked about today. It is known as the transmission medium with the highest capacity and the lowest insertion loss. But we will go into a little more detail about the functionalities and capabilities of this medium. Did you know, for example, that fiber optics do not transmit electricity, but rather transmit light? This makes the fiber optics a medium with very low losses. Did you also know that the optical fiber is designed with a semiconductor material? There is no conductor material, it's a semiconductor. The material used in the optical fiber is silicon. And the way like the optical fiber transmit information to the medium is through internal reflections, as if they were two mirrors trying to confine the light into a nucleus. The main and most used optical fiber is the single mode fiber, where the light will be transmitted in a single way. This is used to prevent that the light takes different paths and present interference. This kind of interference is known as intermodal dispersion. The standard or traditional way to implement a communication network is interconnecting two routers or two layer 2 equipments. This can be done through pluggable interfaces, which have a wavelength depending on the distance they can reach. In the left of the view, you can see a single channel transmission. That is the transmission that is used by the switch or by the router to communicate between two sites, okay? According to the distance, you use the wavelength, 85 nanometers to connect low distance, lower than 100 meters, 30 to 10 nanometers to connect distance lower than 10 kilometers, and for distance higher, you need to connect with 50 nanometers. Therefore, in the market, let's talk about optical fiber again. In the market, you can find three different types of optical fiber. Okay, the first type of optical fiber that we can find in the market is the standard fiber that we know as a standard single mode fiber, SMF, or G6652 fiber. This fiber has a very, very low attenuation in the C band of the optical spectrum, or this is the region of 1550 nanometers. However, the light that travels in this frequency exhibits, in this fiber also, exhibits a large broadening in the time domain as it propagates through the fiber. This broadening is known as chromatic dispersion, and is one of the main problems that we have to transmit low rate information about in the fiber. The transmission protocol that was used in communication networks when the first optical fiber appears was SDH, TDM protocol. And in that time, we don't have technology to compensate chromatic dispersion. Therefore, in that time, the chromatic dispersion was a major limitation in the engineering of the links. So to mitigate this problem, we made another kind of fiber, the dispersion chip fiber. The dispersion chip fiber, or DSF, is also known as G653 fiber. And this kind of fiber was developed with a slightly different type of material, which manages to move the chromatic dispersion characteristics to obtain a value of zero dispersion in the C band. And with this, in that moment, we believe that the DSF fiber was the ideal transmission medium, because that fiber had a very, very low attenuation and zero chromatic dispersion in the C band. But what happened? The SDH system reached the maximum capacity, the 10 gigabits per second, or STM64. And after that, 40G technology wasn't enabled in that time. So the next step in order to increase the bandwidth of the link was to migrate towards technologies that allow multiple signals to be sent over the same fiber. This kind of technology is known as wavelength division multiplexing. And this wavelength division multiplexing technology you can find in the middle of the screen, DWDM transmission. Okay. When we start to transmit several signals over DSF fiber, the signal present great problems due to interference between the different carriers. That problems give the name of nonlinear effects. The nonlinear effects occur for two reasons: high power in the fiber, or because the transmission signals were in a frequency where the chromatic dispersion is zero. So the DSF fiber was zero dispersion in the C band. So the nonlinear effects were killing our signals. After that, the market developed a third kind of fiber, the non-zero dispersion chip fiber, or G655. This kind of fiber has the same behavior in optical losses and has lower dispersion chromatic in the C band, but higher than the DSF optical fiber, okay? In summary, the main limitation for the SDA system, such as chromatic dispersion, the thing that was the main limitation in the beginning, now became an advantage when we want to send multiple simultaneous signals on the same fiber. For this reason, right now, the best option to implement a transmission network, a high capacity and long distance transmission network, is to use standard fiber. G652 optical fiber is the best choice in optical fiber that you can make today for a high capacity and long distance optical network. So let's gonna talk about the ITU recommendation. DWDM is a technology that allows multiple signals to be sent over the same optical fiber. This is possible just if every signal uses an independent frequency in order to avoid interference between the signals. With the current DWDM technologies, we can send from 2, 4 until 88 or 128 signals in parallel through the same optical fiber, depending on the frequency separation that we use for the signals, okay? We must remember that the total spectral width that we can use in the optical fiber to achieve long distance is limited to the C band. The C band is the band where the optical losses are lower in the fiber. There are some initiatives from some providers to use an adjacent band, just as L band. However, they are not very common in the market, and we seek to optimize. What we seek is to optimize the quantity of the amount of information that we can send in the C band. So the frequencies that can be used in a DWDM system are regulated by the ITU, by the International Telecommunication Union, through its recommendation G.694.1. This is the recommendation that ITU used for DWDM frequencies. The first recommendation defines the center frequency and the spacing between each of the carriers in 50 or 100 gigahertz. With 50 gigahertz of channel spacing, you can get until 88 signals, different signals in the C band. With 100 gigahertz, you can have until 44 parallel signals in the optical fiber. In the 2012 recommendation, ITU recommendation, the flex grid solution was introduced. Flex grid solution is the tier one that you find in the figure. Flex grid allows us to have a granularity of 6.25 gigahertz in the central frequency, and you can have a variable width in integer multiples of 20.5 gigahertz. So if you need to transport a 100G, for example, for the 100 gigahertz grid, the fixed grid, if you need to transport a 100 gigabits per second that use 37.5 gigahertz, the signal pass very good. There is any problem, but the spectrum usage, the spectrum usage is very low, because in 100 gigahertz space, you are just using around 30%. Okay, if you use a highest capacity signal, for example, 200G takes around, depending of the optical modulation, the modulation format, you can use around 50 gigahertz. That is around 50% of the grid. So to avoid this waste of a spectrum, flex grid use a lowest signal spacing. Okay, so you can have 100G, 200, 300, or highest capacity signals over the same fiber and use and optimize the spectrum usage, okay? So here is a very important concept to introduce, and it is the relationship between the transmission rate and the spectral width of the signal. The more information the optical carrier has, it is wider in the frequency domain, okay? So for example, we can have 100 gigabits per second signals that use 37.5 gigahertz, like the blue one, and we can have 400 gigabits per second using a 100 gigahertz spectrum. That is this one, okay? So the recommendation, the ITU recommendation, advise all the providers and operators that use DWDM systems to use the same frequency for the implementation of high capacity transport networks. Therefore, a DWDM solution from Pactec, for example, will use the same frequency as a solution from another company, for example, Huawei or Nokia, allowing the implementation of different business models such as alien wavelengths. What is an alien wavelength? If you have, for example, a Nokia optical line system, optical layer, you can implement another vendor, Patek, Huawei, Ciena, Infinera, any of them. You can implement new signals from other providers into the optical layer of the current DWDM provider that you have in your network. That is called the alien wavelength, okay? And it is very, very common here in Latin America, this kind of business model. So after talk about DWDM, let's talk a little bit about reconfigurable optical at-drop multiplexer, about ROADM solutions. The reconfigurable optical at-drop multiplexer, as Anderson said before, allow us to route, add, or disaggregate any of the spectrum signals available in the optical fiber in any of the optical routes available in the system. If you have a node, a site, when you have 5 different or 6 different fiber routes, with the WSS or with the ROADM equipment, you can send, receive, disaggregate, aggregate, pass through any slice of the spectrum in any site, sorry, okay? This type of component has a market of 520 million in 2017 and present a compound annual growth rate of 12% until 2025. This increase is motivated mainly by the increase in data consumption that is a natural consequence of our digital world. Also, due to the motivation of content companies to bring their data to a data center closer to the final user. This is a architecture and that is being used a lot by the content providers. They don't have the big data centers located in USA or Europe. They use local data centers in order to put their content in order to avoid long distance, high latencies, and depend of the maybe a submarine network. They put the content closer to the user in order to improve the user experience. The third reason is because the ROADM architectures has significant advantages in network control and flexibility that we are going to look later. If we look at Omidia reports, we see a significant increase in this type of equipment in metropolitan segments. Why in metro instead the long haul? Because the metro, almost all the traffic is located in the metro, and the metro has a very expectation of traffic increase because the data center interconnection architecture, okay? So in the metropolitan segment, and also in routers that are capable of implementing flexible grid solution, We see in the last slide that if you have a flex grid solution, your network will be more efficiently in spectrum usage, okay? After that, we are going to go in a detail on how to implement a transport network using DWDM technologies. Okay, let's make an example here. You need to connect two sites located at 100 kilometers away. And you need to connect this equipment with 100 gigabits per second data rate by optical fiber. In the left, you have the sites, you have the distance, you have the fiber. In the right, you have the spectrum. Let's see how DWDM is implemented. So the first signal, 100 gigabits per second. How is the connection? What are those components? DWDM technologies make use of a passive element called an optical multiplexer. This one, an optical multiplexer and an optical demultiplexer. The optical multiplexer add all the signals at different frequency and place them in the same fiber pair. These fiber pair are later connected to our dark fiber on the street. After the optical multiplexer, we use an optical amplifier. The technology used in the optical amplifier is erbium doped fiber amplifier, EDFA amplifier mainly. There are also another kind of amplifiers like Raman amplifiers, but in this webinar, we won't talk about the amplifier architecture, okay? So the amplifier prepares the signal, increase the signal level in order to prepare to pass all the distance and all the attenuation that the fiber has. When you need to increase the capacity, you don't need to prepare new fiber pairs. You just need to connect the second signal in a free optical multiplexer port. In this case, the yellow one. You connect the second in a free port, you connect the second signal. In the DWDM signal, compound signal in the dark fiber, you have two signals instead of one. And in the spectrum, you have two signals, one for 100G and the second for 200G, for example. If you need more capacity, like third, fourth, and fifth, you can increase the capacity just adding the equipments in the terminal equipments. You don't need to prepare more optical fiber, to implement another cables, to rent optical fibers from another provider. You have a high capacity network in your network. What happens if you don't have more optical ports in the multiplexer? You can upgrade this multiplexer to a biggest one, or maybe you can increase the data rate of each of the signals. If you start your network with one signal of 100 gigabits per second, if you need an increase, you can implement maybe 200 or 400 or maybe highest capacity wavelength, okay? Okay, it is also important to know the limitation and challenges that we face when implementing a transport network. There is an important compromise, an important trade-off between the rate of the speed at which we want to implement our system and the reach that we can obtain. For example, as we increase the rate is required to use a high-level modulation format. And those high-level modulation format need a higher quality of the signal to operate. Therefore, if we increase the transmission rate, the distance of the reach of the signal decrease. This is very important to dimension our transport network. For example, if you need a long-haul solutions, for example, national solution, for example, submarine solution, maybe the best rate for you is 100 gigabits per second. If you have a shortest network, for example, 100 kilometers, 500 kilometers, maybe you can implement 200 gigabits per second wavelengths. For a metro network, you can use 400 gigabit per second without any problem. And maybe for a data center interconnection that is 80 kilometers or less, you can use 600 or 800 gigabits per second solution. What is the other trade-off? Let's gonna talk about spectrum usage. If you have, for example, 400G in your metro network, you don't know what kind of modulation format used in the network. You have two options. If you use a lowest modulation format, the distance will be increased, but the signal will be higher in the frequency domain. So you lost spectrum, but you win distance or reach. If you have less spectrum, the distance will be shorter. Okay, this is the second trade-off that I want to talk today. Let's move on. So let's talk a bit about provisioning architectures. So imagine that you have a 5-site networks, 5-site, and you want to connect with this traffic matrix. Okay. This could be a real approximation of a need for traffic in a real transport network. So the more basic architecture, what is the architecture with fixed multiplexer, also known as fixed optical address multiplexer. In this architecture, to implement new services, you must carry out physical intervention in our sites to make the connection between the multiplexers from east and west. Let's see an example. For example, the blue one from site 1 to site 2. In the site 1, you connect the signal to a multiplexer, after that to an optical amplifier and to the fiber. In site 2, you need an optical multiplexer going to site 1 that receive the signal and disaggregate the signal. But let's see what happened with the second one, with the yellow one, from site 1 to site 3. So you need to pass by site 2. In the site 2, you need to send someone to make an optical bypass from the east multiplexer to the west multiplexer. From the multiplexer that goes to the site 1 to the multiplexer that goes to the site 3. Okay, this is a manual intervention that you have to make in the network. Okay, for example, in the green one, from site 1 and site 4, you need to make 2 optical bypass in the network. Okay, and for the another solution and the another services is the same history. So what happened here? If you have a biggest network, not 5, mind you, if you have 20 sites, the provisioning times will be higher because you have to program people and material and attenuators, patch cords to make this optical bypass. So your provisioning times will be higher. You also need for manual intervention in the network. You know that this is a risk, okay? And this kind of solution doesn't have any kind of optical monitoring and equalization and control. So the robustness in the network is very, very low toward network impairments, okay? So in order to mitigate the limitation presented in the last architecture, it is possible to update our network using reconfigurable optical address multiplexers. Let's see what happened when we use ROADM architecture in the same traffic matrix in the same network. In order to implement the first service, the blue one, you just need to connect in the site 1 and site 2. Okay, this is the very simple connection. This is the same case in the last architecture. But what happened in the yellow one, from site 1 to site 3? You just have to configure in the NMS the optical trail between the two WSS, okay? You don't need manual intervention. For the tiered service, you can make the trail in the site 2 WSS, in the site 3 WSS. So you have end-to-end service activation directly from the NMS, just remote, okay? So this kind of architecture has very, very low provisioning times. You don't need manual intervention in the network, so the risk of service disruptions is very low. And you have control, as we are going to see later, you have control of optical powers. You can implement automatic equalization. You have flatness control in the network. So the robustness in the network is very, very high, okay? What happens if we include ROADM architecture and we also include OTDR solution? Tech also has a OTDR solution, a very, very compact one solution, that if you have a fiber cut in the network, the OTDR finds the length, the optical length that where the fiber cut or the fiber event is located. Okay. So what do you win with this kind of configuration? The mean time of repair, the mean time between failures is very low, because in a normal solution, in a traditional approach, you will send some guy to site 1 to put an OTDR in the fiber. Okay, let's make the measurement. Okay, we find that 5 kilometers away, optical kilometers, you have the failure, you send the people to the street, find the failure, repair the fiber, come back, measure again. And that can pass some hours, okay? With this kind of equipment, you have real-time monitoring of the network. So the mean time to repair and the mean time between failures are very, very low. So the network availability improves, and the most important, the service level agreement to our customer, our end customer, are improved, okay? So let's talk a little bit about another application. Metro DWDM solution also are a very good solution for Fronthaul for 5G. In the traditional mobile architecture, 3G or 4G, the antennas or the remote stations are connected through data networks because the data rate that is required is very low, okay? So for the next generation network, you have more remote stations, more antennas, and you need much more capacity, much more bandwidth for each remote location. So the technology that we normally use in the transmission network, now we need this kind of technology in the access, okay? So the Metro DWDM networks can also use to implement Fronthaul networks for 5G, okay? The main features or the main functionalities of the ROADM are automatic equalization. When you have a fiber attenuation, for example, the ROADM has optical variable attenuators. So these attenuators can change their value in order to increase the optical power, the output optical power. So there is the optical loss are mitigated directly in the ROADM. You have flatness control in order to have all the signals going out with the same power. And you have the most important, you have monitoring of all channels in all the ports, input and output, okay? So this is, I think, one of the last slides. The PadTech solution. PadTech presents its low cost and low space consumption for DWDM Metro solution. We have different options depending first of the amount of capacity that you need and the amount of capacity that you are going to implement in the day one, okay? I brought 4 examples. In the first one, you have a 40 channels optical layer, 2-degree WSS with OTDR, with EDF amplifiers, optical supervisory channel, and you can have a total capacity of 24 terabits per second in a single fiber pair with just 5 RU of optical layer, okay? If you need something smaller, we can implement in 3 rack units a 8 channels DWDM system. The total capacity of that configuration is 4.8 terabits per second, okay? What happens if you need high availability and you also need capacity installed in that rack? You can have in 7 rack units, 1 terabit per second of installed capacity. And you also have all the features that I mentioned before, okay? And if you need a lowest, you need a smaller DWDM system, you can change the 40 channel multiplexer for 8 channel multiplexer. And in 5 rack unit, you can have the 2 optical layers plus the OTDR. To finish, PadTech DWDM platform allows the implementation of transport solution regardless of the network scenarios, such as national network, a backbone, greenfield networks, and alien wavelength. Submarine line terminal equipments. These kind of equipments also can be installed in a submarine network. Metro networks, metropolitan, high capacity metro networks, corporate access, data center interconnection, and mobile network backhaul. Okay. So this is what I have to present today. Thank you so much for your time and attention. And I give the floor to my teammate, Anderson.
All right, Hernan, thank you so much for your presentation. Well, like I said at the beginning of this webinar, we would like to point out 3 key factors, which are, in first place, have a review of COVID-19 impact on the Caribbean digital infrastructures and how this is linked to the data traffic growth. Then we learned how to boost optical networks, making use of DWDM technologies combined with ROADM architectures, such as Hernan just explained, and thus how to, how this will help you to enhance the capacity through optical fibers. And at the end, we hope all of you understood how PACTES will help you to reduce both capital and operational expenditures thanks to its low-cost ROADM solutions. Okay, so well, for those of you who doesn't know PACTEC, brief overview, we are a Latin American manufacturer, specifically a Brazilian company, with almost 20 years in the market. We are specialized in the supply of turnkey DWDM solutions. Our headquarters is located in Campinas, Sao Paulo State in Brazil. But we also have commercial desks in Argentina, Chile, Colombia, and United States as well. So basically, PACTEC is a spin-off of the CPQD, which is the largest telecom research and development center in Latin America. And that's why we have a very strong, research and development background. Okay, so if you, Hernan, can just please switch to the next slide. Okay, so talking about the geopolitical market, if you take a look to United States, you can find Ciena, Cisco, or Infinera, for example. If we go to Europe, we can see Nokia, ADVA, or ECI. And in Asia, we have Huawei, CTE, FiberHome, Fujitsu, NEC, and PACTEC is the only Latin American manufacturer of DWDM solutions below the Ecuadorian line. So, what is our value proposal for all stakeholders at this present time? Well, PacTech as a Latin American provider and manufacturer of DWDM solutions with a strong background in research and development. PacTech is the local provider offering short delivery times and financing options. We also have a highly specialized and committed close support from all representatives at all levels, from design, commissioning, operation, and maintenance, for example. And finally, our cutting-edge technology for high-capacity solutions that optimizes the capital and operational expenditures. So basically, that's what we had to present today for all of you. Once again, thank you for participating. And if any of you have any questions regarding to this presentation or are willing to have further information, you can reach us to one of the emails below to hernan.jepes@pactech.com or anderson.3ds@pactech.com. So once again, thank you so much for your time and for participating.
Thank you so much. We have one question from Sheikh Hussein, and Sheikh is the chair of our vendors and marketing vendors committee and suppliers committee. And he wants to know, where does G.657 fiber fit into the optical network? Can it be used in the long haul links employing DWDM technology? I'm not sure which one of you would want to take that question.
Teresa, this kind of optical fiber has the same behavior in chromatic dispersion that the standard single mode fiber. So in initial analysis, I think it is possible to implement, but I need to check the other characteristic of this kind of fiber to give a better answer. If he wants, we can contact him in order to evaluate the situation. Okay, but in the first place, I think that is possible because it has the same dispersion and attenuation features of the standard single mode fiber.
Okay, great. And then can you give us an idea, what are your predictions coming out of the pandemic? What are these changes, some of the changes you're seeing for enhancement in optical fiber enhancements?
Anderson, can you answer that?
All right, yes.
Yeah.
I'm sorry, yeah, go ahead, please.
We just want to find out about some predictions. What are some of your predictions coming out of the pandemic? How are companies going to utilize optical fiber to enhance their network?
Okay, I think it is closely related with the topic that we were mentioned previously. The new normal, you know, those uploading content. People is using video conference all the time. People is working home based. So this pandemic has brought a shift from, like I said, from business to residential areas, and definitely this will become the new normal. And as many people say, once the traffic or the traffic levels reach a new level, it won't go back. So definitely we'll have to be prepared and must think about new architectures and technologies to support these requirements of bandwidth and increasing traffic demand.
Thank you so much for that answer. So we've come to the end of today's webinar, which was very informative. Thank you all so much for staying with us, and thank you, Hernan and Anderson, for giving us such good quality content. I just have one or two little announcements to make. Please note that registration is now open for annual conference and trade exhibition. Remember to register early to secure your space. We'll have more great content, premier branding, and superb networking opportunities. Let's remember to keep our distance, wash our hands, and wear our mask as we remain safe amid the COVID-19 pandemic. Thank you, everyone.
Thank you so much for participating and for your time.
Okay, great.